Hello, algebra class. Today we are going to be graphing exponential functions. We're going to only be doing growth functions, and we are going to only do them in situations where we are given the factor. So it's a little bit easier. It's a good introduction to how these look. So just as way of review, growth functions, we are using the format y equals ab to the x, where b is greater than 1. B has to be greater than 1 to be a growth function. A is the initial value, or the starting point, and B is the growth factor, and X is the number of intervals. In the situations that we're using, we're not actually going to call them the number of intervals. You guys know how to manipulate these equations so that you can count by years instead of number of intervals, so we're just going to ignore that for now. But let's take a look at this problem. A colony of 25 fruit flies doubles every 3 hours. Let's come down here to where it says initial value, growth factor, and function rule. You know how to do this already. Our initial value here is going to be those 25 fruit flies, and that is A. The growth factor is the doubling part, so the growth factor is 2. Now this is the part where when we create our function rule, we will need to be careful how the exponent looks. So we're going to say it's y equals 25 times 2, and instead of just putting an x up there, remember we're going to call this x is the number of hours. Now, this doubles every 3 hours, so if I have 6 hours, it's going to be 2. It's going to happen twice. If I have 18 hours, it's going to happen 3 times. So we're going to call that x over 3. So however many hours we have to divide that by 3 to find out how many times this actually happens. So x divided by 3, it doubles every 3 hours. So let's take a look up here at this table. We're going to go ahead and create a table and then graph on this grid over here. Now, the bottom of this grid is going to be our hours, and the side is going to be the number of flies. Okay, so let's take our equation y equals 25 times 2 to the x over 3. And let's choose a few numbers to put in here. Well, I'm going to choose things that are divisible by 3. Because if I choose something that isn't divisible by 3, I will be working with fractional exponents, and I don't want to do that. We could, but I don't want to. So I'm going to start with 0 always. Okay, and then 1 over 3 is going to give me a fraction, so I'm not going to use 1. I'm going to use 3, 6, 9, and 12. Okay? And remember that x is the number of hours that goes across the bottom. So that is 0 right here. And I'm only working in the first quadrant because it doesn't make sense to go back in time. So we're only working in the first quadrant. 3, 6, 9, and 12. Let's go ahead and put some numbers in here. If I have y equals 25 times 2 to the 0 over 3 power, 2 to the 0 over 3 is the same as 2 to the 0 power. Anything to the 0 power is 1. So this is just 25. I'm not putting any numbers here yet until I see how big we're getting at this 12, because exponential growth is like that. It gets big fast. So let's finish the table before we actually label that y-axis. Y equals 25 times 2. The next number I have here is 3 over 3, which is 1. So 25 times 2, which is 50. It's 50. Okay. And probably you can imagine what the next one's going to be, because we're doubling every 3 hours. Let's go ahead and do our function anyway, just so you can see how that works. I put a 6 over 3 in, which is 2 squared. If you need to, you can use your calculator, okay? So that is 25 times 4, which is pretty simple. It's 100. You can see this is just doubling. So that equals 100. Y equals 25 times 2 to the 9 over 3, which is 2 cubed, 2 to the third power, which is 8. 25 times 8 is 200. Think in terms of quarters too. 8 quarters is $2. Y equals 25. This is our last one. Let's put 200 in here. Times 2 to the 12 over 3. 12 over 3 is 4. Okay. 2 to the 4th power is 16. 25 to the 16th power, or I'm sorry, 25 times 16, and we can do that on a calculator if you need to check it, but it should be double that, right, which is 400. Now, I know I'm going as high as 400 on this graph over here, so I'm going to go ahead and make this, let's call these counting by, we can count by 25, so every 4 will be 100. 100, 200, 300, and 400. Okay, so we've got 0. Whoops, sorry. At 0, we are not at 0. We are at, let's use a different color so it's not confusing. We are at 25, so your dot should go here at the 25 mark. Okay, at 3 hours, my dot should go at the 50. At 6 hours, it's going to go to the 100. And you can see already that's not in a straight line. This is not linear. At 9, we're going up to the 200. And at 12, we are going up to the 400. Am I on the right line there? No. Okay, now this is a smooth curve, but it is not a straight line. So you're going to connect the dots. And this is exactly what exponential growth looks like. It's a smooth curve. It increases very rapidly the further you get on. It'll start to look like it's going straight up in the air. Okay? So that is one example. Your homework tonight is exactly like this. You'll have 2 problems to do, exactly like the one I just did for you. And hopefully it'll give you a better understanding of visualizing what this looks like on a graph. So I'll see you soon.